Thank you. Thank you, everyone. Thanks for joining us today. It's with deep felt gratitude I welcome you to H2O Live in 2021. We are here because of the endless support of our community and their pure love, and the great work that the team has been putting in close partnership with our customers. Time is the only non-renewable resource, and nothing but this has been proven again and again in 2020, and the world has been humbled by a pandemic, and here we are trying to make the best out of what we can with the limited time we all have on the planet. H2O started with the vision of making assembly language of AI, ML, scalable and widely accessible across the world. And through that vision, we continue to build AutoML, which will make machine learning accessible to everyone. And that vision continued, and today we are here to talk about the incredible innovation that the team has been delivering with close partnership with our customers. We're so excited to be talking about how to finally make AI consumable by the business audience. Open source is about freedom, not free. And freedom, as you already know, is so precious. We have given that freedom to make to our customers through our partnership with 18,000 organizations, which today depend on H2O AI, some of the most demanding environments in finance, in retail, in telco, and audits. We have some of those customers today with us today to join and talk about their experiences with AI. Tremendous value has been generated. Fighting fraud has been a core theme and one of the earliest use cases for customers, whether in preventing fraud or in trying to look at insurance fraud. We've seen bonds being repriced, 20,000 bonds get repriced every 15 seconds using our open source, several marketing use cases, and to prevent churn and recommend the best products for your customers. Teamwork made the dream work. It was all a dream here at H2O as the video was presenting an incredible timeline of achievement. We started with algorithms, and from algorithms, with every layer of data, whether it was 100 columns or 1,000 columns, or 1,000,000 columns when we were trying to break email marketing and help email marketing for one of our customers, or hundreds of millions of columns in telco customers. Every domain taught us to rebuild our platforms and reinvent the company around it. Today, we are proud to talk about business applications and domain knowledge, which powers all the insights that you need to make data shine, to make decisions. Data is a team sport, and that's true for us and for our customers. And in bringing those different faculties together, the different personas together into one unified platform is where democratizing AI is heading. We're proud to talk about our partnerships with the data engineering platforms like Snowflake, Databricks, Cloudera, and others. Our core innovation, our core community of supporters, data scientists have been thronging to our meetups from the earliest days, using our platform, supporting our AutoML in open source, our ML algorithms, the mojos that allow them to deploy this models to production, automatic machine learning through driverless AI, and then those machine learning operations being powered seamlessly through MLOps. We announced open source Wave. We released open source Wave in December of 2020 through incredible, passionate work from the team. And we've also received incredible accolades as soon as it was released. And we are just beginning in the journey of empowering machine learning data scientists to build applications. Today, we're announcing a platform that allows those open source Wave applications to be built and deployed on a hybrid cloud and an app store that will power reusable components to build pretty much any application in the world. Data prep has been the core place where a lot of data science time has been spent. Here we're augmenting data automatically through other alternative data sources. Our open source modeling framework and closed source driverless AI have been powering a lot of automatic machine learning. Explaining AI is one of the core themes behind how you build trust with AI, and our MLI and Explain AI platforms have been getting some rave reviews. Today, we are here to talk about how to deploy, operationalize your machine learning anywhere and govern them with as seamless nature as you would in making them. Deploying and developing applications is where the last mile is, and that's where a lot of our innovation is being powered. The three innovation leap that we are talking about today, the H2O Wave SDK, which allows you to bring rapid innovation, prototype your applications and ideas from idea to application in very, very short amount of time, and deploy it. Kubernetes completely democratize how to develop and deploy apps at scale. And I think we have embraced that completely. And in the H2O AI hybrid cloud, you're able to now take an application and power an app store locally or publicly and take advantage of the incredible marketplaces out there to build revenue for your ideas. We are really excited to bring several personas behind the complex assembly line of building machine learning applications and AI first applications into a governed, safe environment where you can automatically retrain your models upon detecting drift and automatically look for strong, robust equivalents for an existing model, distill the model to the simplest form factor so you can interpret it and explain it to your business users. Fraud detection applications, automatic time series forecasting applications are here to in reusable components that you can quickly build and deploy apps. Explaining AI is going to be at the heart of every application and not just a post hoc way to build explanations for a model that has been built with complex machinery. We think that explainability and interpretability should start at the data level, not just after building the models. And that's why we made explainability and validation core microservices inside the application, inside the H2O hybrid cloud, so you can essentially build and explain and validate your models, backtest your models in real time while the models are being deployed. We really want our culture of makers to be infectious. We want you to make your own AI, not just consume it. And towards that, the App Store opens up incredible opportunities to take some of the sample applications we have and redeploy them and make them yours. And these sample applications start with vertical applications in finance, in health, as well as data science specific applications that are able to detect drift or automatically document your models in ways that you can provide to your own internal validation frameworks, as well as govern them through regulated processes, such as in healthcare and finance. H2O Wave has come of age, and we would love for you to download the framework, give us feedback. I turned to a few demos here. Our App Store, which is essentially a rich set of applications our team has been building with the help of our customers and bringing these applications to the fore so that customers can essentially take advantage of their data science knowledge. Here, I bring up a LIBOR application. This, as many of you know, in the finance world, LIBOR is coming to an end, and interbank loan documents are being essentially reviewed by manually. Hundreds of thousands of these documents need to be edited and changed, and the equivalent of LIBOR clauses have to be detected. And entity recognition of these clauses, for example, We'll use this contract BERT, which we've trained on contracts, and ability to kind of then detect kind of pieces that need to be changed, organizations, and classify them and assess how much work is needed. How many people will a bank need to kind of go after and training their teams to build and transform these documents. The whole LIBOR migration application is being worked very closely with several of our customers together in the finance vertical. Labeling these documents and then retraining them is just a matter of connecting to driverless AI and rebuilding these models. We think that applications such as these are going to be invented again and again throughout the whole life cycle. One such app is healthcare inventory app. You'll hear from one of our customers later today, Arogya, who are building these applications to essentially drive inventory intelligence across inventory. Applications don't necessarily have to mean verticalized applications. One of our data scientists, Shivam Kagel Master, built an application that can take a Python notebook and automatically generate a wave application for your from Python notebook directly to an application. We think that building and deploying applications will be how AI will be consumed. And data scientists have for a long time been limited by how well they could present their design and how well they can tell a story from their applications, from their work on science. What this is doing is essentially taking what is a concept in a Python notebook or in a data science platform and take it straight to your end users. Other interesting applications, we built a telco churn application for one of our customers in a very short amount of time. And this is the idea here is how fast can people build and deploy models and then connect them back to ML ops, where you can deploy the model and start scoring real time what's really behind the scenes. Models that deploy need to be checked for drift and automatic validation. And we have services, microservices behind the scenes that allow one to do that. But every piece that you're looking at this are all simple Kubernetes deployed services. So customers do not necessarily need to learn how to scale and deploy their own frameworks. Driverless AI, your favorite AutoML frameworks are all connected directly through this end-to-end lifecycle. So you don't have to talk about AUC next time. You can actually talk about credit scores and have that conversation with the business user, not just data scientists. Our goal here is to make AI ubiquitous across the enterprise, across not just the best departments with data scientists, but all the departments in your organization. And that's kind of the core theme behind our innovation, where continued democratization of AI means we can bring folks who are going to be users of AI, not just makers of AI. You're obviously able to take advantage of the best in the world's automatic machine learning, driverless AI, and start building both fairness, explainability, and bias, and detecting bias in your data, and telling the reason codes for what they are, and telling a very powerful story for your innovation. Last but not the least, we think that AI is going to become even more beautiful with the way Wave has come afar. We can see how incredible beautiful templates have been built here. So you can essentially try to make your storytelling as rich and themed as you want. Design is at the heart of evoking that response from your customers and from your users to make them change their mind and make the decisions needed to build that story. Storytelling is going to be at the heart of how AI is going to be really powering decisions of the future. Customer love has been our greatest support and the greatest force for us in our journey. It is with incredible pleasure I invite one of our strongest supporters, both recently, but also in the long journey that we have seen as data scientists. The source origins of R, S, and several of our collaborators come from Bell Labs of AT&T. Today, I have the incredible opportunity to introduce to you one of our strongest supporters for open source from the earliest days in the 2014-15 to one of the earliest winners of our H2O World contest in Kaggle, and more recently, our supporters of driverless AI and the collaboration we are doing with them in the hybrid AI cloud. Without further ado, you have Mark Austin.
All right, thanks, Sri. Let me try to pull up some slides here. All right, great. So glad to be here. Thanks for inviting us. We wanted to give you a few glimpses of applying AI ML for the customer, for operations, and for good. Of course, along the way, we want to kind of weave in how it ties in with some of the H2O open source and some of the great tools as well. But before we do that, Sri started with a timeline. I think it went back to 2012. Let me just rewind a bit before 2012 and talk a little bit about AT&T and the history of AI ML as well. So you could go back all the way to the 1950s. That's where some of the early work out of AT&T was looking at programming a computer to play chess. And then in 1955, believe it or not, the first time artificial intelligence was coined was also AT&T collaborating with IBM, Harvard, and Dartmouth. And then in the 1970s, of course, we had huge innovations coming out of AT&T with Unix, C, C++, and then S, which ultimately turned into R that we know and love. So lots of development in the 70s. In the 80s and 90s, AT&T, Jan LeCun, who some of you may know, applied the first neural network to actually recognizing handwritten zip codes. And some of the foundational work in convolutional neural nets was done. And then in the 2000s, I would say it's a bit all about applying AI ML. But we also, in the early 2000s, Chris Valinsky from AT&T and my group actually won the Netflix recommender competition. And that was a $1 million hackathon. Don't see many of those on Kaggle, but great work there. And now we're all about applying AI in wireless, all of the media stuff, HBO Max, certainly the newest thing there, and then it's on fiber as well. So that's a bit of a timeline. Let me talk a little bit about some of our work and what are we doing to help on the same kind of AI workflow that Sri mentioned as well. For us, it kind of all starts with getting data, creating features, optimizing the AI, deploying the AI, and then of course, maintaining it or monitoring it afterwards. Each of these steps has various issues that I think the industry is addressing. One of the new developments in creating the features, in addition to some of the stuff that driverless AI does, is let's store those and share those. So we're working a lot on a machine learning feature store. Optimize AI has been really a powerhouse. If you think of the H2O, AutoML, and the open source tools, that's been super powerful. The driverless AI, which helps there immensely. All of those are highly used in our teams. In addition, we love the idea of really, I think Sri had it, is data as a team sport. And certainly AI is a team sport. So many times we try to do almost our own internal competitions. So hackathons. So we're deploying AI. We actually created our own internal tool somewhat of an internal Kaggle to do a leaderboard, right? So we want to get the best AI, and we'll take, H2O, driverless AI, AI robots show up on the leaderboard, and then you try to improve on those as well. The new thing that is a great announcement here recently is the H2O wave, taking those great AI and turning those into AI first apps and kind of unlocking it for the business user. So we see a lot of benefit there. And then of course, I think we all have our own ways of not only monitoring, is the AI still good? Is it drifting? But everything around it, because many times our AI and real-time systems is just a piece of the puzzle. So you really need to monitor the whole operations of everything around it. And we go after that as well. So let me switch over and let's talk a little bit about applications. I think you saw Sri talk about fraud. And this is certainly in our industry and many others. If you just look at wireless mobility, it's like $1 billion issue in the industry, right? And it comes in a variety of forms. This is really a moving target, but many of the things is, gaming where, the no intent to pay and the fraudster, tries to get in and they don't pay, or identity theft, stuff that they take off the dark web or other ways of getting it and, masquerading as the user. And then, unlocking phones kind of in a way that we wouldn't like to see as well. So how do you detect all these things? Certainly there's lots of things going on. It's a moving target, but you want to apply rules and machine learning. And just to give you a little bit of illustration, this is a little bit of our journey. I'm showing you just kind of a 3-year picture here. And we used to start with kind of only rules, right? So everybody, when you look at these things, you can catch lots of things by just rules of thumb and things that you can catch there. But it really wasn't until we applied machine learning that we really started to take a dent out of the fraud. And here you're just looking at a 3-year view. So year 2, you can see there's 5 machine learning algorithms deployed here. And you can notice the fraud events are going down. So this is fraud events not stopped, and we're taking it down there. And then year 3, we had great success there with 5 algorithms. We're now up to 26, and it's kind of always growing there as well. But you can see how it's even lower there. Now, these algorithms happens to be, these are all actually deployed with either the H2O open source, driverless AI, or the great mojos that'll actually allow us to deploy these things. So this was a huge success story in actually, going after fraud itself there. So let me give you just another example. This is one that we actually also partnered with H2O, but one of the things that's important to AT&T that is also kind of using AI for good is, certainly we're interested in making sure that our network is up all the time, making sure that if there's a flood risk in any area, that we're moving equipment to higher ground. So we actually started on an initiative with Argonne National Labs sometime back. And I think we took the entire Southeast region and we tried to predict flooding. So looking at multiple years out. And when we partnered with Argonne, it started with a bunch of physicists and supercomputers to actually do this work. And Sri and I actually had a chance to get on a panel and talk about AI for good. And we said, well, maybe we can try to replicate what the physicists and supercomputers folks did with actual AI. Could we replicate the same thing that the physics was producing, but do it with AI and do it much faster? We only had 2 weeks for this actual panel we were going to sit on. So we got the team together. We started thinking about the problem. This is one way to look at it. So on the left there, if you saw that area of the square that I showed you on the previous slide, that was an actual area in North Carolina. And we said, well, that 2D, and if I think about time, time is like how often does it rain over every single day? That kind of looks like almost an image type problem, right? So you could think of like each one of those slices there as a different time. you have all of these points where rain could fall, and ultimately you're trying to predict the flooding at any given point. So how do we do this? Well, I mentioned that we always love to collaborate. We always find that, you know, if you give any problem to one data scientist and you give it, multiply it out to many, at the end of the day, the ensemble of the result is the best. So we partnered with H2O. We also partnered with our own crowd, our internal crowd of data scientists, and you know, we have hundreds of those. And we put it on our own collaboration platform. So this is where we do our leaderboards and we actually compare results here. So what were the results? Interesting enough, you know, as you would expect, this is looking at the, you know, just the error. Of course, the lower error is the better in terms of how accurate you are. And, you know, this is like multiple models. So think of these as parts on the leaderboard. The one on the right is the actual one that we wound up with. But as you would expect, geographical features are important, but also how often does it rain, as you would expect, is important. We started looking at a few days, but ultimately we found that going up to 8 weeks of rain actually was predictive, because you kind of think about it after the fact. It depends how saturated the ground is in terms of whether you're going to have flooding there. Now, the interesting thing, this is another way to look at it. So that was kind of the, you know, the RMSE point of view, but you don't really know what that means until you look at it kind of visually. So on the left was the output of the physics model. Think of this almost like a heat map in terms of flooding correlation versus actual. And on the right is the output of the AI model. And this was done in 2 weeks, you know, with us in our kind of our hackathon type thing. And you notice very close correlation with the actual physics model. In fact, the F1 score you can see is very high there. Now, one last way just to kind of look at this is this is a great video that the H2O team actually put together. And you're looking at the correlation of the flooding of that area over time. The darker the red here is actually the highest correlation. And another way just to kind of confirm that the results actually worked. So anyway, I'd say we, you know, back to kind of the AI vision, all the tools. We love the open source. We you know, we contribute a lot ourselves. We love the tools there. We love some of the driverless AI. We love the vision of turning stuff into AI first with apps. And it's been a great partnership, and we're excited to see what's coming out of H2O this year. Thanks.
Hello everyone, I'm Vijay, co-founder and CTO of Arogya. 2020, COVID-19 showed us the inefficiencies and inadequacies of the healthcare supply chain. The healthcare supply chain required change. We started Arogya to understand what these issues were and how we could solve them. Our vision was to make AI and automation available to all healthcare providers, freeing them from mundane, repetitive, costly processes of managing inventory, orders, and other logistics. Our mission was to enable the move towards robotic process automation, enabling a more robust and predictive healthcare supply chain. The end result would be a no-touch, frictionless, seamless healthcare supply chain. A closer look at the current state. Medical supply chains face tremendous challenges. Beginning with hospitals, they have an inaccurate demand sensing mechanism. They lack forward-looking tools to understand and predict inventory. Similar issues exist with manufacturers and suppliers, and as well as logistics and the distribution centers, leading to inefficiencies in distribution, inability to meet regulatory requirements. Our solution: insights and automation using AI, providing the answers for hospitals so that they could predict demand. They could use easy to use AI apps for inventory management, and they could have a better view of the supply chain. With this particular solution, what hospitals could do was answer basic, simple questions about inventory. What to order, when to order, how much to order, and where to order it from. Having made these assessments and created this particular solution, we started looking for partners. H2O.ai was a clear winner. With their driverless AI, with their app store, with Wave, the solution was very simple. We could easily do it within the time frame of, say, 6 or 7 months. Let's take a look at the solution architecture. So, using API gateways, we collect all of the data from the hospitals, whether it is for inventory management, whether it is for medical records, hospital services, but filter it out currently in version 1 for inventory management. So we analyze this particular data, we provide the necessary outputs. What have we achieved so far? Using H2O AI hybrid cloud models for predicting out of stock, overstock, lead time, supplier risk, consumption rate, we have AI-driven optimization models for efficient inventory management. We also have built Wave apps for simulations, orders, and inventory management. So in effect, the foundation and framework, thanks to H2O, is in place for Arogya. Thank you for listening. Please let us know if you have any questions and would like to understand more about Arogya. We'll be happy to answer all your questions. Thank you.
Hi, everyone. My name is Simon Field. Hopefully you can hear me okay. I've been working at Snowflake for a couple of years now within our field CTO team, and I've been primarily focused with our data science community and working with customers in Europe. It's been great hearing how organizations like AT&T and Arogya are using H2O today to address their data science needs. And I'm excited to talk to you about our partnership at Snowflake and the integration we have with H2O. But first of all, let me introduce you to Snowflake a little bit and the evolving data cloud on our platform. So until now, organizations have always struggled to centralize and combine their data and process it efficiently for insight and analytics at scale. This has become even more challenging in an ever more connected world where businesses need to collaborate and share data effectively and securely, both within and outside of their organization in order to deliver new digital and AI services. So this is the fundamental problem that Snowflake is solving. It's the age-old problem of data silos, but on a much grander cloud and cross-organizational scale. And the data cloud is an evolving network of thousands of organizations who now use Snowflake's platform to share and collaborate more seamlessly with data. So it's interesting to hear the kind of app store analogy around AI. We're kind of working with customers in the same way with data and providing an application store or a data marketplace. Our platform enables three key things: access to all your data and the ability to receive, share, and join internal data with data from other organizations without the need to move or copy it. The ability to govern and control access to data to support that collaboration whilst maintaining the highest levels of security and compliance. And action to support every part of your business with the elastic processing capacity needed to make faster decisions with data. So the platform provides a familiar database-oriented approach using SQL to not only define analytics and data structure, but also to define Snowflake services and infrastructure. And as you'll see shortly with H2O, now with the ability to define data science with SQL. Our service separates storage from compute and compute from compute. Users and teams share and work with the same live version of the data using dedicated elastic compute called virtual warehouses, each of which can be scaled up and down, started and stopped instantaneously and independently as needed, and all with a utility pay-per-use charging model. We support a wide variety of data formats and workloads, including data pipelines, ad hoc exploratory analytics, reporting and dashboarding, that kind of data sharing and marketplace capability, and of course, data science. We run on the 3 largest cloud providers today with the same identical functionality, providing both portability of processing and data and cross-cloud use cases. So we collaborate extensively with data science partners like H2O to build great end-to-end experiences, exploiting core and new Snowflake innovations. We have a great engineering partnership with H2O and many joint customers. In fact, AT&T is a joint customer. So H2O can deploy and operate on the same cloud providers and regions as Snowflake, providing close affinity for data and processing with Snowflake. Let's look at an example of the kind of advanced data science capabilities that Snowflake supports. So we've recently added the ability to work with unstructured data in addition to structured and semi-structured capabilities we're best known for. We support streaming ingest of new data as it becomes available, for example, landing in cloud file stores or from a message queue. And Snowflake tasks can then execute SQL processing on any new data arriving in the stream, making use of functions written in other languages and reaching out to external web services if needed. In this example, data is read from a stream and passed as a web service for processing via a Snowflake external user-defined function. The web service uses a model performing speech-to-text transcription, and it returns the output into a Snowflake table as semi-structured data. And our next stream in the pipeline picks up that new transcription data from the table, performs entity object and sentiment classification on the text, and writes its output into another table. In this case, the classification model and code is executed inside Snowflake using SQL and a Java user-defined function. So data scientists and analysts can immediately query the new data and use it to build new models for quality of service, customer satisfaction dashboards, etc. Now let's see how H2O's integration with Snowflake makes use of some of these innovative new Snowflake features. So H2O have built an end-to-end integration with Snowflake using external functions to interoperate with services in H2O. I can now run a simple SQL query which passes data collected and prepared in Snowflake and train a model in H2O with AutoML. I can monitor the training process from SQL commands as it progresses. And once the training is complete, I can choose the optimal model for my problem and get the SQL command that wraps the H2O deployed prediction service. I can pass new data from Snowflake to the model for further validation and use it for bulk or near real-time predictions. We can use Snowflake streams and tasks to automate the execution of those predictions on any new data as it lands in Snowflake tables. And I can persist the predictions and the model explanation into Snowflake tables further downstream for further downstream applications and users to consume. I can also deploy the H2O Java model object into a Snowflake Java UDF to execute the prediction directly inside Snowflake service. And all this without leaving my Snowflake SQL session. So we can now build robust data and model ops processes and pipelines that automate the training, scoring, monitoring, and retraining of models. Data engineers and scientists can collaborate and easily deploy new models without the frictions of the past, or getting models off the workbench and into live and monitored production settings. So we've only had time to skim the surface of Snowflake and H2O's combined capabilities here. Hopefully this has excited you about the possibilities to streamline your data and process and model processes and encourage you to explore further. You can read more on our website or feel free to reach out to me directly via email address or LinkedIn. So Snowflake and H2O, it's a great combination. Snowflake excels in providing the data. H2O excels in delivering the science. Thanks for your time today. Enjoy the rest of the session. I'll pass it back over to Sri.
Thank you, Simon. Super excited for the partnership with Snowflake and making our customers successful. We have learned here at H2O that's almost always easier to build a long ecosystem and raise a forest, not just a tree. Open source naturally lends itself to long-term thinking and building communities that thrive. And what we've learned over the years is that we can't build everything, but what we do build, we want to build world class. We partner with both the data providers, data platforms, much like Snowflake, but also we can connect to 200 plus data sources inside H2O hybrid cloud. The H2O AI hybrid cloud architecture runs in Kubernetes, which means your favorite flavor of Kubernetes, whether from OpenShift, Red Hat, or VMware, or HP, you are, as a customer, can rest assured that if you have an on-prem play for AI, this is going to be the platform that allows you to seamlessly go between every cloud architecture out there and also serve your business consumers on-prem. Red Hat, OpenShift, and H2O have been working very closely to make it easier to deploy and manage the H2O AI hybrid cloud on-prem. A lot of our customers are going to take advantage of the tight-knit integration with OpenShift, and we are super excited at being able to serve their workloads on-prem and in the cloud. Let me tail back to the product for a quick second. COVID-19 has anything but shown how incredibly powerful data architectures can be and how one can essentially start building supply chain optimizations in healthcare. Our healthcare professionals are our superheroes, and they need to be powered with the best in technology that we can give them. One of the things that we were building as we're building models, some of our top data scientists and grandmasters were in the service of helping our customers build their models and build them and build forecasts, predict demand. It's unfortunate that our models were in the main predicting the second wave, and we've seen that in spades here. One of the things we learned in building those models was that back testing your models across the time was just as important in healthcare as it is important in trading and platforms. So we built a backtesting framework that allowed our customers to go back in time and assess weekly how the demand was outweighing their supply. This particular work was open sourced for our end user community. Our Kaggle grandmasters have been working with both the customers and payers and providers to bring that kind of collaboration between the teams. Another place where we spent some time was predicting supply chain optimization for essentials such as cleaning supplies or across different geographies, bacterial detergents, and so on and so forth. We found that the rate at which the data was changing in the run-up during COVID meant that you couldn't build a time series model from last year, the year before seasonality. One had to rebuild those models, augment them with COVID data, and rebuild and look for where the supply is positively correlating to demand, to cases, and where it was negatively correlating to cases. The green line here is demand for product such as cleaning supplies or toilet paper in response to COVID situation. In the end, what the overall partnership with the several healthcare communities and public health organizations proved to us was the crazy ones are the superheroes, our superheroes, healthcare workers worldwide. Thank you so much for your input, for your sacrifice and putting your lives at risk to save ours. And no words can express the gratitude we have for the work you've done. As a result, we invested in H2O AI Health. I'm proud to announce that we built what is the beginnings of a very long-term investment in the space. Our vision for a 2050 H2O AI is we'll be known for our health work. In 2070, we'll probably be just a nonprofit helping the world get better and hopefully build enough to democratize health through AI, through open source, and through care. We're super excited to be part of the change we would like to see in the world. Health is, after all, the most valuable thing one can have, and nothing but 2020, the key cornerstone of story of 2020 and COVID-19 has exposed the inequities in the space. We think that given enough eyeballs, all bias is shallow. And we announced an Institute for Fairness in AI Foundation, and we think that fairness in AI is not just a good to have, it is an essential for building trust and defining measures and removing bias from data. So models can be trusted again, and models can be deployed without any worry about the core concept of driving inequity in the historical data. Our vision here is to build a consortium of academic practitioners, business folks from both regulated industries of finance and health, and make fairness in AI a cornerstone of deploying machine learning and making all software AI first. Fairness would be an essential ingredient for building that trust. Our automatic bias detection, adversarial testing in the platform, as well as our ability to detect drift and retrain the models is something that we've added as a core piece to the platform. And that, we think, will be necessary for building a very robust AI-first ecosystem. Let me show one of the apps that our team has built, which allows that ability to kind of detect and look for drift in your data and not wait for the models to not wait for external changes to rebuild your model. Backtesting should happen almost automatically. You can see how variable importance in the data has changed across several models, and detecting that drift and retraining the model is as good as using a microservice in the platform. And streamlining machine learning operations is really how we can make AI safer and easier to deploy. In summary, H2O AI Cloud is going to make it easier for both developers and data scientists to take their ideas and imagination and power the future of innovation. I end with something that is of incredible value for all transformation in all life as well as organizations. As AI decides to change the world in more ways than one, we feel like empathy would be the cornerstone of this transformation. Empathy to our customers, empathy to our neighbors, empathy to each other, so we can build a world that we can all be proud of. And like someone said, today is hard, tomorrow will be worse, but the day after tomorrow will be beautiful. To be alive is to have the courage the world needs of us today. And with that, I take this incredible opportunity to thank the team, the community, my customers. Thank you, Mark. My partners. Thank you, Simon. And Arogya for democratizing health and AI. This is just a beginning of a long journey. We're still in the earliest innings of AI. And I thank the community and the entire organization for the incredible opportunity to talk to you again. Looking forward to a H2O world soon.